Year after year, a team of scientists has been observing Brazil's forest fires during the dry season. They've been trying to find out what impact the fires have on the environment. On board this monitoring flight over the Amazon rainforest are atmospheric scientists from the Max Planck Institute for Chemistry in Mainz. They are measuring so-called aerosols, tiny airborne particles from exhaust emissions and the burning forests. There are many different kinds of particles, and the scientists can get an idea of where they've come from and how they may have gotten into the atmosphere from their shape. They find pollen. They also see crystals of sea salt, as well as grains of sand from the desert and masses of soot particles from forest fires and industrial emissions.
If we added up all the surface areas of all the particles in the atmosphere, we'd end up with a surface area roughly equal to that of the entire globe.
And what does this mean to the chemists?
It means that you have an enormous surface area where reactions, mainly chemical reactions, can take place.
The atmospheric researchers are using a huge hollow glass sphere to study certain chemical reactions. In the apparatus, they disperse the particles to create different kinds of aerosols. Currently, the scientists are especially interested in soot from forest fires. These particles form extensive clouds of dirt, as seen in this satellite picture.
What's apparent here is that you can't see the ground beneath this dirty cloud. That means the sunlight reaching the ground is definitely affected by this cloud. You can see that it isn't white, but gray.
Gray clouds allow less sunlight to penetrate than white clouds do, making temperatures under gray clouds cooler. This also means that beneath gray clouds, less water evaporates from an ocean's surface, resulting in less rain. In addition, particle aerosols can also hamper or prevent rain formation in the interior of the cloud. The atmospheric researchers in Mainz are trying to simulate the process in a wind tunnel. How long do the water droplets remain inside a cloud? How large do they have to be before they fall to the ground? And how is this process affected by the presence of certain particles? The answers to these complex questions can help explain atmospheric processes.
The droplet is not a rigid sphere or a rigid mushroom-shaped body. It's a moving, rotating, oscillating object. This host of movements means that, for example, it undergoes chemical reactions differently, with a different efficiency than if it were a rigid, hovering sphere.
The bottom line is, particle aerosols can prevent rain. This could happen, for example, in the polluted air over Asia's huge cities. But it could also occur in regions suffering from large-scale forest fires. The presence of many soot particles in the air leads to the formation of many small water droplets, too small to be released from clouds as rain. As a result, these regions may experience drought. Instead of falling as rain, the water droplets, together with their soot particles, ascend to higher layers of the atmosphere, where the airstream can carry them away, even to other continents. There, the consequences can be catastrophic. The water, which other regions have been deprived of, may be unleashed in massive storms and floods. A small simulated forest fire in the laboratory is one more way of studying the secrets of aerosols. Sometimes, simple experiments can answer the most delicate scientific questions.